This is lesson 52, adding rational expressions with unequal denominators and also overall average. So the first example, we have these two fractional or rational expressions and we need to add them together. And we've seen this sort of problem before where we need to get a common denominator. The only difference is we now have a little bit of more complex denominator here with two terms being added together. But the same rule applies. The same rule applies with numbers, with variables. If you can get a common denominator, then you can add them. And so the common denominator for these two fractions would simply be x times x plus y. So I'm simply just multiplying those together since there's really not an LCM that I can find besides that. So if I multiply x times x plus y, I also have to multiply the numerator a times x plus y. And then I have to do the same for the other side. If I multiply x plus y times x, I also must multiply the numerator b times x. And now I can consolidate these into one fraction with x times x plus y on the bottom. And then the top, I would have a times x plus y plus bx. Now, I could simplify this. There are a lot of different ways I could show this answer. One way would be to use the distributive property on the top, and I would get ax plus ay plus bx. And then I could also use the distributive property on the bottom, which would give me x squared plus xy. So that's one possible answer. There are a lot of different ways to write the answer, and it really just depends on what you're doing, but this one is the one I'll circle here, although this one also is the correct answer before I use the distributive property. So let's do a second example. Example 2. Now you can try this one on your own. I'm going to give you two rational expressions, so 4x plus a over a plus b plus c over x. So first, try to find the common denominator by multiplying the denominators, and then remember to multiply the numerators by the same thing you multiplied by the denominators, and then see if you can simplify it a little bit. So go ahead and pause the video. So let's go ahead and take a look at what we've got for the common denominator. We just have a plus b and we multiply it by x. And so for the first one, I multiplied the bottom by x, so I also had to multiply the top by x. Same for the other fraction. I had to multiply both the top and bottom by the other denominator, which is a plus b. And then I could put it all into one fraction over x times a plus b. And this is actually an acceptable answer, or you could use the distributive property to simplify or to expand it a little further. And then you would get 4x squared plus ax plus ca plus cb over ax plus bx. So let's look at a couple more examples. So example 3, go ahead and write down this example, a plus b over x plus c over m plus d, and try to find the least or the common denominator and then simplify the answer. There are many possible answers, but try to expand it. So pause the video. Now checking the answer for example 3, the common denominator would be m times x. And once we simplify and expand everything, we would have am plus bm plus cx plus dmx over mx. The last example for this topic, example 4, I want you to try this one on your own as well. So x over y minus b plus c plus d over m. So find the common denominator and simplify as much as possible. You can pause the video if you like. Now checking the answer for example 4, the common denominator would be m and y together. So each fraction gets multiplied. The first one gets multiplied by m. The second, since the denominator was 1, we had to multiply by both y and m. And the final one, we multiplied both by y. And then just expanding everything with the distributive property, we get mx minus by plus cy plus dy all over my. And now we have one remaining topic that we'd like to talk about today, and that's overall average. Now for the second topic of this lesson, we're going to talk about overall average. So let's look at an example here. Let's say that an average score of class A, they have 90%, and there's only 5 students in that class. And the average score of class B is 80%. And now this class has 20 students. Some people might be tempted to take the average of the averages by adding 90 plus 80 and dividing by 2. But this isn't really fair if you think about it, because one class has a lot less students than the other class. And so the overall average, another way to think of it, would be the weighted average. Takes into account how many pieces of data are in each data set. So what we do is we take 90%, we take the score of 90, and we multiply it by how many people or how many subjects were in that experiment or how many points of data there were. So we multiply that by 5. And then we're going to add 80 multiplied by 20. And then we're going to divide the sum by the overall number of data, which would be 25. Now this is going to give us a more fair estimate of the overall average. So go ahead and calculate the overall average of these test scores. So let's check our work for this. If you multiplied and divided correctly, we should get 82, or I guess 82% in this case. That would be the overall average. And we notice this is not the same as the average of averages. If we had taken the average of averages, we would have added 90 and 80 and divided by 2, and we would have got 85%. So you can see that the fact that there are 20 students here pulls the average down, since there were only 5 students here, which makes the overall average less than the average of averages.